We're looking at homework from section 4.1 today. This is question number 11. The data given below show the number of overtime hours worked in 1 week per employee. Use the data to complete parts A and B. So we have overtime hours that range from 0 to 6, and then the number of employees in the next row. Part A wants us to construct a probability distribution. And in part B, we want to graph the probability distribution using a histogram and describe its shape. So the first thing we need to do to convert our frequency distribution into a probability distribution is to add up all the values of the employees that we have. So we're going to take the 5 plus 14 plus 26 plus 59 plus 42 plus 28 and plus 17. And when we add all those up, we get 191. That number will be the denominator of each one of our probability fractions. So now we look at our x values, which represent our overtime hours, and we're going to find the probability of obtaining each one of those values of the random variable x. So we'll start with 0. There were 5 employees that had 0 overtime hours, so we take the 5 and we divide it by 191. 5 divided by 191 is 0.026, rounded to 3 decimals. For employees that had 1 overtime hour, there were 14 such employees, so 14 divided by 191 is 0.073. With 2 overtime hours, there were 26 employees. 26 divided by 191 is 0.136. Employees having 3 overtime hours numbered 59, so 59 over 191 is 0.309, rounded to 3 decimal places. Employees that had 4 overtime hours, there were 42 of them. 42 divided by 191 is 0.220. Employees that had 5 overtime hours, numbered 28, so we take 28 divided by 191, and that's 0.147. And for the employees that had 6 overtime hours, there were 17 such employees. 17 divided by 191 is 0.089. So these are the values that we use to fill in the table in part A. In part B, we're trying to choose the correct graph for the probability distribution. We need the values from part A to figure that out. So when we look at our values from part A, the highest value was when x was 3. The probability of 3 was 0.309. That means we're looking for a graph that has its highest bar when x equals 3. There are 2 graphs that have the highest bar when x equals 3. Those are graphs A and B. So immediately we can eliminate graphs C and D. Let's also look for the lowest value of a probability here. The lowest value for a probability was the probability of 0. That value was 0.026. So the highest bar should be where x is 3, and the lowest bar should be where x is 0. So when we put that second criteria into the graph, that makes us choose choice B. Okay, so the lowest bar is where x is 0, the highest bar is where x is 3. The correct choice here is option B. Now option B looks pretty symmetric, right? It's not completely symmetric, but we would say it's approximately symmetric, but not uniform. And that's the answer to question 11.